Good morning, students. Today we are going to study the fourth experiment, that is colorimetric determination of copper. So colorimetric determination of copper is a spectrophotometric analysis where in this experiment we are using digital photocalorimeter. So when the name itself is mentioned as calorimeter, that means we will be using the colored solutions. So for the determination of copper sulfate solution is having light blue color, but to get a deep blue color we have to add ammonia and prepare a complex solution. So when you add ammonia to copper sulfate, it forms a complex called cuprous ammonium sulfate complex, which is having deep blue color. So by using digital photocalorimeter, we have to estimate the amount of copper present in the given copper sulfate solution. In this experiment, we have to understand 2-3 words. Here we are passing the light radiation. So when the light is passed through a filter of fixing a particular wavelength, then you will get a monochromatic light. Here the wavelength of the radiation what we have to use to measure the absorbance of the solution is 620 nanometers. So that means we have to fix the filter to 620 nanometers. So when the light radiation is passed through the filter, which is fixed to 620 nanometers, then whatever the monochromatic light you will get through the filter will be having 620 nanometers. So when you pass the light radiation through the colored solution, that is the complex solution of cuprous ammonium sulfate, when the light is passed through the color solution, some amount of the light will be absorbed. So now we are using this instrument, the photo-digital colorimeter. We are going to measure the amount of light absorbed by the colored solution. So a mathematical expression is there. It works on the principle of Beer-Lambert's law. You will be studying in theory also the derivation of Beer-Lambert's law. Beer-Lambert's law states that absorbance is equal to epsilon Ct. Epsilon is the molar absorptivity constant, C is the concentration of the solution, and T is the path length of the solution. That means when you are passing the light radiation through the solution, it depends on concentration, it depends on path length of the solution. So when you are increasing the concentration, the absorbance increases because A is proportional to C. So the absorbance increases with increase in the concentration of the solution. So please keep in mind that this instrument works on the principle of Beer-Lambert's law, and passing the light radiation having a wavelength of 620 nanometers through the colored solution, and we are measuring the absorbance of the solution. Okay, now coming to the demonstration of this experiment. For doing this experiment, we have to take a series of standard solutions of different capacity. Of this is labeled 50 ml standard flask we have taken and labeled them as blank, 5, 10, 15, 20, 25 and test solution. So we need these standard flasks of 50 ml capacity and labeled as blank, 5, 10, 15, 20, 25 and test solution. Okay, to do the experiment we need 2 burettes. In one burette we have to take copper sulfate solution of 50 ml capacity. In the other burette we have to take 1:1 ammonia solution. Please carefully understand here. We are taking a series of standard flasks and we are taking 2 burettes. In one burette we are taking copper sulfate solution. In the other burette we are taking 1:1 ammonia because we have to form a complex solution of cuprous ammonium sulfate. Okay. If you first we have to prepare the series of standard solutions. For that first we have to take the standard flask labeled as blank. Blank means in this we are not taking any copper sulfate solution. Okay, we are taking only ammonia solution of 5 ml. Okay, so we are taking 5 ml of ammonia into this blank solution. So we are not taking copper sulfate into the blank. Okay, we are keeping it here. Now we are taking the second flask labeled as 5. In this 5 indicates that we have to take 5 ml of copper sulfate into it. So we have to take 5 ml of copper sulfate into the 5 labeled standard flask. Okay, after taking 5 ml of copper sulfate, now we have to add 5 ml of ammonia. See, you are getting color because of the formation of the complex, cuprous ammonium sulfate complex. See, I am repeating. I have taken a 5 labeled standard flask. In this, I am taking 5 ml of copper sulfate, means from 0 to 5 ml of copper sulfate, and to this I am adding 5 ml of ammonia solution and keeping it here. And now I am taking 10 labeled standard flask. In this, I have to take 10 ml of copper sulfate. That means already up to 5 I have added. 10 ml means 5 to 15 ml. So you have to take 10 ml of copper sulfate, and again you have to add 5 ml of ammonia into this, and we have to keep it here. And next we have to take the flask labeled as 15 ml, and this we have to take 15 ml of copper sulfate. That means already it was here 15. So 15 plus 15 becomes 30. So we have to run down the burette up to 30 ml of copper sulfate, and to this again you have to add only 5 ml of ammonia, and we have to keep it here. Now again we have to take the flask labeled as 20, and this 20 ml of copper sulfate we have to take. That means from 30 to 50. You have to run down the burette, so it becomes 20 ml of copper sulfate, and again you have to add 5 ml of ammonia, and we have to keep it here. Now we have to take 25 ml labeled standard flask. Again you have to fill the burette up to 0. Now you take from 0 to 25, so it becomes 25 ml of copper sulfate, and then you are taking 5 ml of ammonia, and you are keeping here. Now you have to take the test solution. The test solution will be given by the examiner. So in this test solution, you should not add any copper sulfate because copper sulfate is already given by your examiner. So now to this you have to add 5 ml of ammonia. Okay. Now these flasks, I am repeating, blank, we are not taking copper sulfate, taking only 5 ml of ammonia. 5, 10, 15, 20, 25. We are taking according to the numbers corresponding amount of copper sulfate. In all these flasks, we are adding 5 ml of ammonia including the test solution. Okay. And after adding ammonia, now we have to make up the solution up to the mark with the distilled water. With the distilled water, we have to make up the solution up to the mark because we are saying that these are the standard solutions. So when I add water, you will get solutions of this type. See the color of the solutions: blank, 5, 10, 15, 20, 25 and test solution. If you see the color intensity increasing from 5 to 10 to 15 to 20 to 25 because we have increased the amount of copper sulfate solution. So with increase in the concentration of copper sulfate, the intensity of the color also increases. So this is the first part of your experiment, that is the preparation of standard solutions of cuprous ammonium sulfate. Okay, this is the first part of your experiment.